In a recent video, I showed that the multiplication of two continuous functions is continuous itself at a particular point. I also, in that video, included a section where I talked about how the exponentiation of two functions is also continuous, but that kind of relied on the fact that the composition of two functions is continuous. And I didn't want to let that go. I wanted to make a video about it, so here it is. So recall that if you have functions that are continuous at a particular point, let's say x equals c, so let's say f, the function f, is continuous at x equals c, then what that means is f of c is going to be equal to the limit as x approaches c of f of x. Now, we need two functions, so let's also have g of c. G of c is going to be the limit as x approaches c of g of x, as we have established. And what we're looking for now is f of g of c. Okay? So is f of g of x, or f, you can also use the notation f of g like that, of c. I personally hate it because I always read that as fog, but we're really looking for the composition here. So f of g of x, is that continuous at x equals c? So let's use our limit properties again. So remember that what this is saying is that f evaluated at g of c, meaning that we can plug in the fact that the limit as x approaches c of g of x is equal to g of c. So this equality made it so that g of c turns into this. So we're taking f evaluated at the limit of g of x. Now the thing is because f is continuous, we can actually take this limit outside of the function and put it in front of f. That is yet another limit property regarding all these things, all these continuous functions and stuff like that. So what we can actually say is that this is going to be the limit as x approaches c of f of g of x. And that's equal to f of g of c. So we have this limit equal to that, and you can pretty much see it's the same sort of setup here. We got f of c, and then we have the limit of f of x. Here we have f of g of c, then the limit of f of g of x. So there we go. We proved that the composition of two continuous functions is continuous itself. So I've made videos on addition, which also kind of ties into subtraction. I've done multiplication, which also ties into division, exponentiation, and now composition. So I think I've covered pretty much all the operations you can think of. If you have any more in mind, then please let me know. But I hope you enjoyed this video, so thank you so much for watching, and I'll see you in the next one. Bye, guys!